Okay, today we're going to talk about Unit 4, Lesson 3, the Sun. Your Indiana State Standard is 6.2.3. Also, this is similar to 5.1.2. Understand that the Sun, an average star where nuclear reactions occur, is the central and largest body in the solar system. Here comes the Sun. What do we know about the Sun? The Sun is a hot ball of gas composed mostly of the elements hydrogen and helium. The Sun formed about 4.6 billion years ago. Of the light emitted from the Sun, 41% is visible, that means the light that we can see. 9% is ultraviolet, that's the stuff we protect our skin from, UVA and UVB rays. And 50% is infrared radiation. Without the Sun, there would be no life on Earth. It really keeps the plants growing, keeps the Earth warm so humans can inhabit it and other creatures and living things. The structure of the Sun is a spherical body with a layered atmosphere and an interior or an inside that's made of layers also. Energy is made in the core or the middle of the Sun and is transported to the surface through the radiative zone and the convective zone. The Sun's atmosphere has 3 layers. On the atmosphere, remember, this is the atmosphere, the outer of the Sun. We have the photosphere, the chromosphere, and the corona. The Sun's surface part is the photosphere. Energy escapes the Sun from this layer. The middle layer of the Sun's atmosphere is the chromosphere, and its temperature rises with the distance from the photosphere. So the farther you get away from the photosphere, the higher the temperature is. The Sun's outer atmosphere is called the corona, which extends millions of kilometers into space. When there is an eclipse, the corona is often what you see shining around the object blocking the view of the Sun. Structure of the Sun, we have the radiative zone, we have the core, the radiative zone, and then the convective zone. And then up here is the photosphere, the chromosphere, and then the corona. So you can see that here on page 181. I would like you to read the section called What is the Structure of the Sun and do question number 7, Analyze. Please pause the video now to do that. Let's get together. How does the Sun produce energy? Matter can change into energy according to the equation E equals mc squared, where E equals energy, m is the mass, and c stands for the speed of light. The Sun generates energy through the process of nuclear fusion. This is a process by which 2 or more low-mass atomic nuclei, this means low-mass atoms like hydrogens, for example, they're number 1, they're the smallest on the periodic table of elements, they would come together, they would collide together and form a new, heavier atom or nucleus. Remember, nucleus means the middle of the atom. Nuclear fusion takes place in the core of the stars. So in the center of the stars where fusion is happening. In stars with core temperatures similar to the Sun's, the fusion process actually starts with the fusion of 2 hydrogen nuclei. In older stars with a hotter core, helium fuses into carbon. Okay, I'll go ahead and pause the video again and read page 182. How does the Sun produce energy? And by nuclear fusion. And then if you want to give number 9 a try, this is a great chance to see if you actually understand the process of nuclear fusion. Mixing it up. How is energy transferred to the Sun's surface? Energy is transferred to the Sun's surface by 2 different processes. Energy can be transferred from the Sun's core through the radiative zone by radiation. And this happens from the top of the radiative zone through the convective zone to the photosphere by convection. So it's going, remember, if you need to look at that picture again, the radiative zone is right outside the core, and then the convection zone is just past the radiative zone, and the photosphere is the surface of the Sun. Energy travels through the radiative zone in the form of electromagnetic waves. We've studied electromagnetic energy before, and that's how energy is traveling in that zone of radiation in the Sun. Remember, the radiative zone is just outside of the core. The radiative zone is densely packed. That means the particles are really tightly packed together, and those particles are things like hydrogen, helium, and free electrons. Electromagnetic waves are repeatedly absorbed and reemitted, absorbed, reemitted by particles until they can reach the top of the radiative zone. After the radiative zone, then they can be passed to the convective zone, and that's where energy is transferred by the movement of matter. Hot gases rise to the surface of the Sun, cool, and then sink back into the convection zone. We've talked about this process before in class. We've talked about it in your home with your furnace, where you have an intake of the cool air molecules. It gets taken into the furnace, heated up, released out into the air through a register in your room. And then as the molecules cool down, they sink and get taken back into the furnace. Same thing in a convection oven, where the air swirls around your food and is constantly heated, and as it cools, it gets reheated to make a more even cooking environment for your food. Same thing is happening on the surface of the sun. This process is convection, and it takes place in convection cells, which actually form granules on the sun's surface. So it's happening in these convection cells on the sun. Go ahead and pause the video and read how is energy transferred to the sun's surface. Also read by radiation and by convection on page 184. We'll do the convection lab one day in class. How does the sun rotate? Because it's a giant ball of gas, the sun rotates faster at its equator than it does at the higher latitudes. So this is called differential rotation. Unlike the Earth, it's a ball of gas. So the middle is going to rotate faster than either of the poles. Near the equator, the sun rotates once every 25 days or so. But at the poles, it's going to rotate once every 35 days or so. The sun's interior does not rotate that way. Actually, the sun's core and the radiative zones move together at the same speed. Go ahead and pause the video and answer the question, at which point does the sun rotate fastest? The sun rotates fastest at point A, the equator. Remember, that's every 25 days, while at the poles, point B, it's every 35 days. The Ring of Fire, what is solar activity? Solar activity refers to the variations in the appearance or energy output of the sun. That means how the sun looks or how much energy the sun is giving off. Solar activity on the sun's surface includes three things we're going to talk about in this lesson: sunspots, solar flares, and prominences. Dark areas that actually form on the surface of the sun are called sunspots. They're about 1500 degrees Celsius cooler than the areas that surround them, so they appear as a dark area on the surface. Sunspots can range in width from a few hundred kilometers to 10 to 15 times the diameter of the Earth, so very large. Sunspot activity occurs on average in an 11-year cycle, in which the activity will increase and then decrease in that 11-year time span. Secondly, we have solar flares. Solar flares are an explosive release of energy that can extend outward as far as the sun's outer atmosphere. They kind of look like little volcanoes on the surface of the sun. They're obviously not a volcano, but that explosion or release of energy sort of gives you that shape. During a solar flare, the sun actually ejects large amounts of high energy particles, along with radiation from across the entire electromagnetic spectrum. So that means all kinds of radiation is coming out. This is why during a solar flare, we've had many of these this year, seems an increase than previous years. We worry about, during a solar flare, things like cell phone service being interrupted or radio or television waves being interrupted, because we're sending a signal from a satellite down to your cell phone or your television, and a solar flare with all these high energy particles released into space, it can actually interrupt that signal. Temperatures within a solar flare can reach millions of degrees Celsius, so they can be very hot. Lastly, we're going to talk about a prominence. Prominences are huge loops of relatively cool gas that extend from the photosphere out thousands of kilometers into the outer atmosphere. Several objects the size of Earth could actually fit inside of a loop of a prominence. So remember, a solar flare is more of an explosion, and a prominence is a loop of cool gas. Prominences generally last from several hours to a day, but they can last for as long as several months. All right, go to page 187. I want you to do number 14, comparing and contrasting solar flares and prominences. I also want you to take a look here at the pictures. Solar flare, remember I said it kind of looks like a mini volcano, just as an explosion. It's just straight out in the air. However, a prominence creates this loop, so it's definitely something different. Cool gases here, high energy particles being emitted there. Okay, what's the structure of the sun? Let's look at this picture. I want you to pause the video as I point to each of these three pictures, and I want you to figure out which one is which. So the first one we're going to point to and pause. This is a sunspot. Okay, I want you to look at the second one. I want you to pause it, and when you think you have the answer, start it again. This is a solar flare. And lastly, pause it again. This loop is a prominence. Okay, I want you to do questions 1, 2, 3, 5, 7, and 10 on page 189. I also need you to fill out your visa. Please remember that when you're writing a summary, it's not that you did the video notes for homework, it's what the video notes were actually about, something you learned in the video notes. Also, when you're doing an illustration, it's a picture about something in the video notes. And finally, when you're writing a question, something you had a question about in the video notes. Or if you didn't have any questions about the sun, then you need to write a test question and include the answer. Please remember to get a signature either by myself if you finished them, if you had a chance to do them in class, or if you took them home, they need to be signed by a guardian or a parent.